Quadrilaterals is four-sided shapes. We knew, I don't think this is new to you, but now we're talking 360 degrees altogether. If it has four sides, you are guaranteed that all four angles add up to 360. Very important, because if they give you all but one, you can use this property to find out the missing one. Then we talked about quadrilaterals, and this is the big umbrella, okay? These are all quads, but they have three different camps, okay? We talked about all of these ones here. I don't know if you see that they're related if you think about it. The parallelogram and the rectangle are related, except for the parallelogram is slanted. I don't know if you see that, right? Take a rectangle, slant it, you've got a parallelogram. Take a square, slant a square, and you've got a rhombus. Okay, so that's how these two are related. So they have just one difference, basically, and that's how you can distinguish one from the other. Okay, so all of these ones here have these properties in common. So if you want to, maybe for now, just make a note, just remember that. Okay, two pairs of parallel sides, two pairs of congruent sides, and diagonals bisect, which means they cut each other in half. Okay, so that's on 25. Let's keep going here. I'm going to talk about each one of them separately. I don't know how full your study sheets are. I haven't looked at them. Some of you are making new ones all the time, but you should have, for each one of these shapes, at least two properties either written or labeled on it. Okay, so here we go. Let's start. I'm going to use, so a parallelogram, what do we know about it? This is one property right here. If you do this and this, as well as, I'm going to stick to the bottom here, that's one property. Okay. Another property is that this side measures the same as that, and this side has the same length as that side. That's another property. These are new right here. That there's a long and a short diagonal. Do two different pens for this one, markers, whatever you want. Whereas the long diagonal, it's this one right here. This one is longer, one that's shorter. But the property doesn't lie there. It's actually in what follows. We know that these lines cut each other in half. So this would be 1, 2, 3, and this would be 1, 2, 3. Why are you using 3, Mr. Erickson? Because I already used up 1. I used up 2. Now I'm saying that this stretch is the same as that one. And I have to use 4. 1, 2, 3, 4. 1, 2, 3, 4. So they cut each other in half. You may put a point down here if you want. So I'll say this. Two pairs of parallel sides. Two pairs of congruent sides. It has diagonals bisect. That's it. I'm just going to leave it there. So those are 3 properties there. Rectangle. What's different about this one? I'm going to use a highlighter for this. What do you think the diagonals are going to be on this one? Are they going to be different, or are they going to be the same? The diagonals. The same, right? So I'm going to use green. Okay. This one has a lot of properties we can talk about. We can say that this side is the same as that. So is this side. Okay, so 2 pairs. That's still the same. These are the same in that regard. This side is parallel to that side. This side is parallel to that side. They never touch. Okay. What else do we know about the angles of a rectangle? What do they measure? 90, correct? That is actually a property. So don't overthink it. Sometimes you know it. You've known it for a long time. That is also true about it. And this is how this one is different. All of these that are cut, right? The diagonals, when they cut each other, they're all the same. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So all of these segments are actually exactly the same, unlike the parallelogram, because one diagonal is longer than the other. So 2 pairs of parallel sides, 2 pairs of congruent sides, diagonals, watch this, bisect and are congruent. That's how it's different, right? It's bisect and are congruent. All 4 angles are equal to 90 degrees. So actually we have more to say about that one. Okay, so that's how you would distinguish a rectangle from a parallelogram, but they're cousins. Think of it that way. You just need to know. I'm going to say this. You ready for this? Most of the questions on the exam regarding quadrilaterals are going to be short and sweet. They're going to ask you, hey, what do you know about a rectangle? One question, and you're going to see it in one of the ACs if you get it. Someone is looking at a chocolate bar. What makes it a rectangle? It's got 4 90-degree angles. 1 out of 1. Done. Right? So sometimes students want to overthink it because it's a provincial exam. It's not always don't bother overthinking it. Okay? Let's keep going. Oh, should I do the difference between this one and this one? Is right here. This part and this part. That's how they're different. Okay, next, rhombus and square. A rhombus is also going to have a long and a short diagonal. So I'm going to use 2 different colors for that one. Okay, so there's my long diagonal. And there's my short diagonal. Boom. What is still the same from before? Hey, you know what's different about a rhombus is that all 4 sides are the same. A rhombus is a slanted square. You know what? I'm going to ask you to write that down. It's a slanted square. Put that in your study sheet. That helps you, right? Because then you know, oh, then all 4 sides must be the same. And the diagonals bisect each other too. Watch. So you're going to go 2 and 2, as well as 1, 2, 3, 1, 2, 3. Okay, so they're cutting each other in half. That's what you're telling the audience there. Another thing is, watch this one. This is key. I'm going to use orange for this one. They actually meet at a 90-degree angle. That's very particular to the rhombus. So put a little 90 there. The diagonals meet at a 90. So 2 pairs of parallel sides. 4 congruent. This is the symbol for congruent sides. So they're all the same. Diagonals bisect. Diagonals. What's the word for meeting at a 90? Starts with a P. Perpendicular. You've heard of that before, correct? I hope so. Diagonals are perpendicular. I think you should graduate with certain things that you just know, right? And this is you can do that, or meet at a 90. To be honest, on the exam, if you make your point come across, you quite often get full marks. Okay. What will make, so these are related. What could you do to a rhombus to turn it into a square? What's that? 90? Turn all the angles into 90s, you've got yourself a square. Okay? All four sides are the same. You've got 90s everywhere. And the diagonals are the same, so I'm going to use the same color as before. These diagonals are actually exactly the same. There's no long, no short. Do you think they meet at a 90? The answer is yes. They meet at a 90. But they also cut each other in half. But they all measure the same. Okay. So, I'm missing some labels. I'll do that later. Two pairs of parallel sides. Four congruent. I'm just going to use the symbol for this. Four congruent sides. Diagonals bisect, and watch this, and are congruent. Four right angles. I think we're good. There are more, but we're not going to explore them all. If you have two for each, you're actually in good shape. If you know two properties of each, you're probably in pretty good shape. Let me go back and do the parallel sides, okay? I didn't do that. So this side is parallel to that one. This side is parallel to that one. That's how you indicate lines are parallel. Boom, boom, and then arrows like this. Sometimes the province says you can use markings. Sometimes they tell you write it. So just be prepared for both. Okay. Bring a ruler to the exam, okay? Worst case scenario, you forget. You draw yourself a rectangle or a square, right? You make yourself a square. Make sure all sides are the same and then measure the diagonals, right? If they are the same, then in fact they are the same in real life, okay? So if you run out of juice, that's what you do. Keep going, 27. Right trapezoid and isosceles trapezoid. These are the only two trapezoids we have in this unit that we explore. Ready? Marking wise, the right trapezoid, guess what? It's going to have a 90 here and a 90 there. For sure. This line and that line never meet, so you can go like this. Are they congruent? Are they the same? We cannot say that. Okay, we cannot say that they're congruent. So here we go. Two right angles, one pair of parallel sides. That's it. That's it. A right trapezoid is cut off on one end, basically, compared to the isosceles trapezoid. You remember isosceles? You have two sides are the same. Two sides are congruent on a triangle. There's also an isosceles trapezoid. So this side is the same as that side. And these two are parallel to each other. These ones are not, correct? The sides, if you were to extend them, they would actually touch at one point. They're not parallel. One more here. The diagonals are congruent. So going from here to there is the same distance as going from here to there. So here we go. I will say this, two parallel sides, two congruent sides, I'll say it this way, two pairs of congruent angles. Say what? Angles? It's a chopped off isosceles triangle. Think of it that way. It's a chopped off isosceles triangle. So this angle, I'm going to use a different color, bring this to life a little bit. This angle is going to measure the same as this one. Okay? So that's a marking. And these two up here, this one is going to be the same as that one. That's what I mean with two pairs of congruent angles. Diagonals are congruent. And I know some of you can write extremely small. You probably fit all properties on there just in case. The diagonals of this one up here, one would be short, one would be long. They don't bisect, so we're not talking about it. Okay. And the last one, the kite. How many trapezoids? Only two. How many of the first category? Four, right? You've got the parallelogram and the rectangle. You've got the rhombus and the square. They're kind of related. And then we've got the two trapezoids. And here we go, the last one. Do we still fly kites these days? I did. I made my own back in Paraguay. We had bamboo. We had garbage bags. So you would like get some bamboo together, some string, garbage bags. Man, those things, that was a lot of fun. Until my friend thought that putting a razor blade on his tail was a good idea. And he tried to, like with all flower kite, he would try to like make his tail hit your string, and then your kite would just go in. Super dangerous. Don't do it. Don't do it. Not recommended. He put many razor blades on there, actually. Anyways, yeah. Broken glass. That's still not safe, but it weighs you down, I guess. I don't know. Broken glass. Yeah. Anyways. Yeah, no, not hit, but he cut mine. He cut mine off. Yeah, yeah. So you would release a roll of string this big until the kite was so small that you could cover it with your thumb. Right. That's how high that thing was, and it stayed there all day. Probably not safe either. In the city, not smart. Different country, different continent almost, right? South America. All right, let's keep going. Kite. What do we know about a kite? That the diagonals, they meet at a 90. So let's write that down. Diagonals are, if I say this, will you know what I'm talking about? They are T, upside down T. No, they're perpendicular. I'll just go perp like that. This side and this side are the same, and so are these two. Okay, so two pairs of congruent sides. Two pairs of congruent sides. Oh yeah, and last but not least, the short diagonal bisects. The short diagonal. Which one is the short one? This one right here. So we go 1, 2, 3, 1, 2, 3. So when the diagonals meet, the short one gets cut in half. The long one doesn't. Is there anything else that I would like you to know about this? Yes. An old exam question. Let's see if you fall for it. If I shorten this one, if I shorten the bottom, think of two triangles stacked, two isosceles triangles that are stacked together. If I make this one the same as these ones, what shape am I turning it into now? If all four sides were to be the same, it actually turns into a rhombus, not a diamond. Okay, some students put down diamond. Never have I ever taught of a shape called a diamond. Okay, so no diamonds in this unit, just kites and rhombus and so forth. Okay, all right. Uh, one more thing. You got to take a red pen or something that stands out, which is a pretty good property. It will help you figure out missing angles. Okay, so here we go. No matter which side you come at it, okay, from like if these are the parallel sides, if you come at it from this angle, from this side here, these two add up to 180. No surprises because they're both 90, right? But I can also guarantee you that if you came at it from this side and you were to add this angle and that angle, it's also 180. What does 180 and 180 add up to? 360, which is what we expect for all four-sided shapes. Okay? Think of it that way. So go to all of these and tell yourself that coming from the ends, right, you got a 180 sum here. So if you know the bottom, you can easily find the top and vice versa. Let's go to the previous page, 26. I'll do that to every single one of them. I do that at the end because then you see that they're all sharing that property. So this is 180. This is 180. I think you get the point. Maybe you don't need to do this to every single one, but I will do it so that we're all on the same page. Did I tell you every single property of every single shape? No. We'd be sitting here for a very long time. Okay. I do not give you all the properties. You might find out some new ones. For example, a rhombus, can I tell you? It will just tell you this angle right here is the same as this angle here. And this angle right there is the same as that one right there. That's also a property, but you got to stop at some point or else it becomes too overwhelming. You don't need to know all of them. You just need to know 2 or 3 of each. Keep going. If I ask you to sketch the following and label 2 properties, could you do it based on your study sheet? So I'll do a model one for you. Kite. What does a kite look like? It looks like this. And so now you're going to make sure 2 properties, almost as if you're reading out 2 properties. What's one property that you could make a note of? The one I'm going to choose is I'm going to make 2 diagonals like this. And I will say that I know that those 2 meet at a 90. That's one property. Then you're going to say, I'm going to say, oh, well, I know that this stretch from here to here is the same as this stretch from there to there. 2 properties. So diagonals are perpendicular. That's one property. And short diagonal bisects. You don't have to write it, but I'm just letting you know that's what I did there. Let's pretend like we're doing one from scratch. We're doing it all over again. So this is a different student. This student chooses to look at the study sheet. She's like, hey, I know that this one is the same as this, and the long sides down here, they're the same. Property number 1. Property number 2, I'm going to say that this and these diagonals, they meet at a 90. So diagonal is perpendicular to pairs of congruent sides. Oh, by the way, all angles are still add up to 360 on this one too. It's 4-sided. I didn't tell you that I feel like it's important. Can we go back to 27? That's what happens when you freestyle. Can I just make sure this one is actually benefit, like this angle right here is the same as this one right there. So one pair of congruent angles. One pair of congruent angles. Only that one where the short diagonal connects them. Just think about it. Two isosceles triangles stacked, right? If you stack two isosceles triangles, then their sum is still going to be the same. All right, let's go back to 28 now. That's all I wanted to add. Okay. Let's go back to 28. Here we go. You want to do another one? I'll do one more, just so you understand that there's not one right way of doing this. You could say this angle is the same as that one, and these two sides are the same, so are these two sides. So one pair of congruent angles, two pairs of congruent sides. Voila. Can I ask you to do it with the rest? There's some on 28, some on the, you don't have to do 3 versions of everything. Just do 28, 29, one diagram per version, but it looks boring. You call that fun, right? Okay, so let me clarify, okay? Some students may think that I'm changing my notation. This, an equal sign with a third wave, means congruent, which means equal. I just need you to know the terminology so that when the exam throws it at you, you know what I'm talking about. You know what they're talking about. It seems like I've had 2 students approach me already, say that I've made this. These are the same. If I made that little house thing, it's the same as this one. I meant to do this one, okay? So my bad. My bad. It's just equal sign with a third squiggly line means congruent. Yeah. Yeah. So the quiz is next Monday. And then Wednesday we write our test and then we're done. Okay. All right. I'll do 2 with you. Right trapezoid? You should know what it looks like at the very least. That's a right trapezoid. One property, boom. Another property, boom. You're done. That's it. You can't even do more than that. Next, parallelogram. It's a slanted rectangle. If you need to add this to your study sheet, go for it. So think of a rectangle that is slanted a bit. You know that these two sides are the same, so are these two. That's what I'm choosing to label. Don't just talk about one pair that is congruent. Talk about, right, in terms of the sides, you've got 2 pairs. The next one I'm going to do is I'm going to choose to include my diagonals. And I'm going to say that this stretch is the same as that. And this stretch is the same as this stretch. Okay. There we go. Could you have done more? Yes. You could have talked about parallel. So I'll do this quick. This is probably a cleaner version. Right? 2 pairs of parallel sides. And then we can do this one where we say, hey, this one is the same as that one. It's a longer diagonal. And the short one also gets cut in half. That's what bisecting means. Okay. I've just done that in science. No. You dissected something. Bisecting is cutting it in half. Unless you did cut a frog in half. I don't know. Let's go working with quadrilaterals. Come with me here. This is page 30. and then I'm going to let you do some work on your own, and I will circulate and help you out. Okay? Given the quadrilateral below, what type is it? Classify it. What do you think this is? It's definitely a trapezoid, correct? It's not good enough. What is it particularly? Is it a right trapezoid or is it an isosceles trapezoid? Okay, got it. Okay, okay, you are listening. Okay, isosceles trapezoid. Why do I know this? The base angles are the same, right? 60 and 60. That basically gave it away that it's an isosceles, okay? Because you got these two are the same. What else can I find? Determine the values of angle A and angle B. How do we find A here? Remember the thing I made you do for every single shape? What do we know about these two? What do they add up to? 180. Okay. So I will say that angle A is going to be 180 minus 60, which is 120. So we know now that this is 120. It must be. There's no way around it. It has to do with the parallel lines, by the way, more so than anything else. What do you think this is going to be? 120. Yeah, it's 120. It's the same. Because if this is 60, you subtract that from 180. I'll still go the long way. Hey, there's an even longer way. You want to see it? You don't seem excited. 360 minus 120 minus 60 minus 60. You know what you get? 120. So it doesn't matter if you use sum of four-sided as 360 or if you use the property I just gave you, you should always get the same answer. It should jive. Okay. Next. You're with me, right? What is the length of side AC? Here you got to do some math. Okay, so you gotta follow me along here. Oh, actually, this one not yet. Sorry. What's side AC? Everybody, point on your paper. Where is AC? Right there. This side right here. So side AC is equal to 4 centimeters. Because these two are the same. I know that already because it's an isosceles trapezoid. Area of a trapezoid. I'm going to show you this, but it's not very popular. Okay? For area, you need the height. You need A. This is A. This is B. And this is height. The height is always measured at a 90. Okay? What do we know about this? The bottom is worth what? It's 9 centimeters. The top is 5. Okay. I want to cut this out here and figure out the height. I know that this is what? What is this one right here? Look at the top. It's 4 centimeters. Okay. This is how you find the height. This is where Pythagorean theorem is going to come in and save the day. This is 4. This is h. What in the world is this? Anybody? Let's call this x. This one right here is x. Can I go 9 minus 5? Yes. X is going to be 9 minus 5. And I'm going to split that in half. So 9 minus 5 is 4. Divided by 2 is 2 centimeters. So that's what goes here. Why am I dividing it by 2, you might ask? Well, how many x's are there? There's one here and one here. So if you subtract 5 from 9, if you take this away from 9, you still got to split it into 2 equal parts. Okay, to get your 2 centimeters. What am I missing here? Leg or hypotenuse? leg, right? Okay, so h is going to be 4 squared plus or minus? It's minus because I'm subtracting. I go hypotenuse minus leg. 16 minus 4 is 12. Root of 12 is 3.46. I don't know if I've ever shown you this, but I'm going to stick to 4 decimals there. This is important to my operation here because the area, remember, area is A plus B, 5 plus 9, multiply that by the height, and then divide that answer by 2. That's 14 divided by 2. So you grab your calculator. I still have this number on my screen here. So I'm just going to go times 14 divided by 2. It's 24.25 centimeters squared. Remember, area is always squared centimeters or squared units. All right. $34, right? I'm going to ask you to do one on your own here. Go to page 31 and try that one. Because I want to do a kite yet. So go to page 31, give it a go, using this as your model. Guys, go to 32. Go to 32 real quick. When you want to, you know how you always divide by 2? Like here you would go the base minus the top divided by 2 to get this little stretch here, right? You do not need to do that with a right triangle. Well, right trapezoid, right? Because there is no, you're not splitting that difference equally. You just like subtract and then you're left with this little stretch here. Right? Okay, let's keep going. Let's go to 33. Hang in there, guys. We're almost done the course, but you gotta stay. I can't force you to follow, right? But you gotta try. Given the quadrilateral below, answer the following. Determine the value of x, y, z. Oh my goodness, these angles drive me nuts, right? X, y, z. Where's that? Where's that? X, y, z. So they're asking for this one right here. Okay, highlight that. Do whatever you need to do, but that's the one they're asking for. What do you think angle y is? Hint, hint. 101 degrees. I told you that in the properties that if this is a kite, then those two are the same. So you can actually write in 101 here. Determine the value of Wx. Where is Wx? That's Wx right there. What do you think that's going to be? 2. Okay, Wx is 2 centimeters. You can write that in, 2 centimeters. Wait a minute, that's it? Yep, that was it. What do all 4 angles always add up to, folks? Say it. 360, all in unison. 360, right? 360, that's always there for you. What about this triangle? If I were to just take this triangle, it would be 180, right? But if you take the whole thing, it's 360. Let's keep going. Calculate the length of WY and XZ. What are these called? They're called diagonals. Right? WY, XZ are diagonals. And here's the fun part. I at least think so. This is trig review. What do we know about these two sides? What do they measure? Look up. 2 and 2, correct? What do these two measure? 3 and 3. Do we know this angle here? I was nice enough to give you that one. It's 58. What does this look like? Side, angle, side, this triangle right here. There's a triangle right there. It's SAS. That's cosine law, right? Last time I checked. So why don't we call this lowercase z here? So we're going to go z squared is equal to 3 squared plus 3 squared minus 2 times 3 times 3 times cosine of 58. Anybody do this already? I don't have my key ready for this one, do I? Oh yeah, I do. Never mind. That would give you root of 8.461, and that keeps going. And there you have it. It's 2.91 centimeters. So be creative. Try to transfer information. Try to look at it from various angles and try to see, can I do this? Question, could I have used this triangle up here? The answer is yes. But you need this angle here. But Mr. Dirksen, I know 3 already. Yes, go 360 minus 101 minus 101 minus 58. You get this one up there. You should get the exact same answer. Okay, or else math just crumbles. Everything falls apart. Right? So this is Z. Just make sure you don't think it's 2. Okay. Next, XZ. Let's call this N. I don't know. Let's call it that. We know this is 3 and this is 2. We happen to know that this is 101. I'm going to focus on that triangle right there. I know what some of you are thinking, Mr. Gerson, could I like split this up into maybe right triangles? You can, but it's going to get complicated. Is it? N squared. 2 squared plus 3 squared minus 2 times 2 times 3 times cosine of 101. That gives you 15.289 and something, which in turn gives you 3.91 centimeters. There you have it. So you solved for the long diagonal and the short diagonal just like that. By the way, this was SAS again. If you ever see area of a kite, I'm not going to ask you to figure that out, but you've got triangles here. So if you find the areas of those triangles, you can figure it out. Oh no, I'll just give you the shortcut. Yeah, you ready for that? I know, we're almost done. Go to 34 and just write this down. I don't really need this to be on your study sheet because the province won't, but I might on a test or quiz. Area of kite is long diagonal, short diagonal, divided by 2. That's how the quickest way of doing that. I could show you why that works, but it just works. Long diagonal times short diagonal divided by 2. So we have those 2 diagonals on the previous question, so we could figure it out. I'll just give you the answer. Answer would be 5.69 centimeters squared. So if you want to construct a kite and you need to know how much fabric you need, now you know how to do it. Funny. Okay, so I will say this. I will bunch up a bunch of answer keys, but you go page 35 to 48. There's a bunch of them. Okay. Do I expect you to do every single one? I would like you to. I know it's sometimes not realistic, but having it all blank is not trying, right? You need to know what trying looks like. It looks like having stuff on some of those pieces of some of those pages. What are we doing tomorrow? No, not doing this class. That's in the morning. But yes, tomorrow we're doing polygons. Okay, that's our last grader topic. So make sure you're here for that. Thank you for listening.